Aloha protocol. So here any station can transmit data to a channel at any time. It does not require any carrier sensing. And the third point is collision and data frames may be lost during the transmission of data through multiple stations. And next one is acknowledgement of the frames exists in Aloha. Hence there is no collision detection. And the last point is requires a retransmission of data after some random amount of time. So these are all things we already discussed in the last video. So there are two different types of Aloha protocols. One is pure Aloha, another one is slotted Aloha. So today we'll see what is pure Aloha. So what is pure Aloha? So the original Aloha protocol is called pure Aloha. So the original Aloha protocol is called as pure Aloha. Here each station sends a frame whenever it has a frame to send. That means whenever the data is there, so without considering the time, it will start sending the frame. After transmitting the data packet, station waits for some time. So once the data packet is transmitted by a sender, so it will wait for some time. It will wait for random amount of time to get the acknowledgement from the receiver. So if receiver sends the acknowledgement, when it is sending the acknowledgement, when the data packet is correctly received at the receiver side, then the receiver starts sending the acknowledgement to the sender. So that's why the sending station waits for some time after transmitting the data packet. Here there is only one channel for them to share. So only one channel is there for sender and receiver. That means more number of stations can share only one channel. So two possible cases for pure Aloha is there. So what are the two possible cases mean? First one is transmitting station receives an acknowledgement from the receiving station. So what is this transmission station receives an acknowledgement? So sender and receiver is there. If sender sends the data, so receiver side it receives the data, we need to receive the correct data only, correct and meaningful data only. If it is corrupted, then it will send the negative acknowledgement. Otherwise sometimes the data is lost in the middle, then the receiver does not receive any data and it will not send any acknowledgement. So when the receiver receives means the sender receives the acknowledgement mean the transmitting station assumes that the transmission is successful. So two cases are there. One is transmission is successful and the other one is transmission is unsuccessful. When we call the transmission is successful mean transmitting station receives acknowledgement from the receiving station. Then the transmission mean the sender assumes that the transmission is successful. And the other case is transmission is unsuccessful. So when the sender assumes transmission is unsuccessful, if the transmitting station does not receive any acknowledgement within the specified time from the receiving station, so within the stipulated or specified time, the acknowledgement is not received by the transmitting station, then the transmitting station assumes that the transmission is unsuccessful. What is the meaning of unsuccessful? The data may lost in the middle or the data is corrupted due to some collisions. So like that some disturbances happen for successful transmission of the data. So these are two possible cases for pure Aloha. So what are the two possible cases for pure Aloha? One is transmission is successful and the other one is transmission is unsuccessful. So here is one of the example for frames in a pure Aloha network. So here we have four stations are there, that is station 1, station 2, station 3 and station 4. Now the four stations wants to transmit the data at any time. So as the concept of pure Aloha, any station can transmit data at any time. That is the main point which is used in the Aloha protocols. So here also we have 4 stations are there. So here the stations channel is same, means all the 4 stations used the same channel, and the timeline is also same for the 4 station. But for clear understanding, here we are separating the timelines. So this is the timeline for station 1, this is the timeline for station 2, this is for station 3, and this is for station 4. So for understanding purpose, we are written in a different timelines. But actual concept is all the 4 stations uses the same channel at same time period also. So if you observe here, some stations means some of the frames are collide and some of the frames are correctly received, means correctly transmitted. So we'll see what are the frames correctly transmitted and what are the frames are colliding each other. So as per the pure Aloha's concept, any station can transmit data at any time. If it is having the data, then it will start transmitting. So if you observe the diagram here, the station 1 starts transmitting the frame 1.1. So here the station 1 starts transmitting the first frame, that is called as frame 1.1. So at this particular point of time, no other station starts transmitting any frame. So frame 1.1 is started transmitting by station 1, and at the particular point of time no other station starts any transmission. So that's why the frame 1.1 will not be collided. Maybe it will be transmitted successfully. Next, at the timeline, I mean if you consider the timeline series, next the frame 3.1 is started transmitting by station 3 at this particular point of time. So at this point of time, the station 3 is start transmitting, and if you observe the diagram, no other station is started any transmission. But after some time, the station 2 starts transmitting the frame 2.1. So here frame 3.1 is already using the channel, means already in the shared memory, and at the same time frame 2.1 is also in the same shared memory. And after that time, again frame 4.1, station 4 starts transmitting the frame. Likewise, frame 1.2 is also started transmitting by station 1. So if you observe, during this time period, frame 3.1, frame 2.1, frame 4.1, and frame 1.2, all the frames are using the same channel, same shared media. So before this duration, this frame 3.1 is started, and after this duration of time, frame 1.2 is free. There is no collision for that. But during this duration of time period, the collision will happen with these frames. So because same channel is there, at the particular time, frame 3.1 is started transmitted, frame 4.1 is also transmitting, and frame 2.1 is starting, and frame 1.2 also using the same shared channel. So it leads to collision. It leads to collision. Next, coming to the next one, after some time, frame 2.1 starts transmitting the frame. So frame 2.1 is started and no other transmission is there in the shared channel. So what will happen? Meanwhile, after some time, station 4 again starts transmitting 4.2. So if you observe, here is one shared medium is there which is collided with frame 2.2 and frame 4.2. So this period of time is called as collision duration. Collision duration. Collision duration means what the time period we will consider. In that particular time period, the frames are in the shared media. Then we considered it as collision duration time period. Later again station 3 starts transmitting frame 3.2. At that particular point of time, there is no stations started transmitting any frames. Now you can understand. So at any station, different stations can use the same shared channel at a particular time. So here, as per the knowledge of pure Aloha, the stations will start transmitting the data at any time. There is no time limit for any station. There is no slot for any station here. So if station is having any data to transmit, simply it starts transmitting the data. So sometimes there may be a collision will occur due to the transmission of stations at a particular time. Two or more stations want to transmit the data at that particular time, then it leads to a collision. So if collision occurs, then there may be a chance of colliding of the frames that leads to errors or corrupting of the data or data lost. So this is the concept of pure Aloha. So we'll see what is the theoretical part of this pure Aloha. First one is pure Aloha allows station to transmit whenever they have data to be sent. So in pure Aloha, when the station is having the data, so simply it starts sending the data. It starts transmitting the data. Next, when a station sends data, it waits for an acknowledgement. So if the station is starts sending the data, then again it will not sending any data to any other station. It will wait for some time. Why it will wait for some time? It will wait for the acknowledgement. It will wait for the acknowledgement. Next, if the acknowledgement does not come within the allotted time, then the station waits for a random amount of time called back of time. So, if the acknowledgement doesn't come within the allotted time, so within the allotted time, if the acknowledgement is not received by the sender, then the station waits for random amount of time. Why we called it as random amount of time mean each station is having a different time slots, different amount of time. It will wait for different amount of time. That's why we called it as random amount of time, and simply we called it as back of time TB, T sufficient B. So T sufficient B is called as back of time and resend the data. So stations wait for different amount of time, then the probability of further collision decreases. So if the stations are waiting for different amount of time, so for example, station 1 starts sending the data, next it will wait for some time. So it is, if it is in waiting time, then there may be chance of another station to start sending the data. So what will happen here? Station A is in waiting state and station B is started sending the data. That means the channel is utilized by station B but not by the A because A is in waiting state. So it leads to decrease the happening of the collision. Probability of collision is decreased here if the stations are waiting for the acknowledgement. Next, the throughput of pure Aloha is maximized when frames are of uniform length. So if the sending frames are of equal length or uniform length, then the throughput of the pure Aloha is maximized. Whenever two frames try to occupy the channel at the same time, there will be a collision and both will be destroyed. So we already discussed this one. If two or more frames, we saw in the diagram also. So here frame 2.1, 3.1, 4.1 and 1.2. So when two or more frames overlap means occupy the same channel at the same time, then it leads to collision. That is the point here. So whenever two frames try to occupy the channel at the same time, there will be a collision and both will be destroyed or both will be corrupted. Next, this is the important point. If the first bit of a new frame overlaps with just the last bit of a frame almost finished, both frames will be totally destroyed and both will have to be retransmitted later. So what is this point? What is this point mean? So here is one diagram. See, So here we have sender A, B and C are there. So now if you observe, this is the timeline. So this is the timeline. So timeline T. So when B starts transmitting the data here, so it is sending the data. So when it starts sending, there is no transmission of frames from A or C. So simply B starts transmitting the data and it is in the completing stage, means at the last moment, at the end of the frame B, the station A starts transmitting the same channel. A starts transmitting the data in the same channel. Then what will happen at this last point, means last bit of B, means it is going to ending, means it is in the final stage to transmit the data successfully. But at the final stage, at the end of B, the station A starts transmitting. So during this time period, what will happen? Again collision will happen. So even though the B is at ending stage and A is at starting stage, both both B's frame and A's frame is colliding each other, and both will destroyed, or both will collided, or both will corrupted. Understand the point? Means it will be collide at any point of time. It is at the starting position, or it is at the ending position, or it is at the middle of the position. So whatever may be. So the if two frames are collided, then simply both the frames are destroyed. So that is the point explained here. If the first bit of new frame overlapping means using the same channel at the particular time, with just the last bit of a frame almost finished. So before the transmitting frame, whatever is there, that is almost in the finishing stage. But the first bit of new frame is overlapping with that last bit of the frame. Then what will happen? Both frames will be totally destroyed. Means because of collision, both frames will be totally destroyed or corrupted, or errors will occur. So what it leads? It leads to retransmission of the data frames again. It will leads to the retransmission of the data. So if the frames are collided at any position, then simply we need to retransmit, because both frames are collided. Both frames are corrupted. So again it needs to retransmit the data. So that is about this diagram. Next one. So transmitting stations uses a backoff strategy. We already discussed. What is this backoff strategy? So if the station is not receiving any acknowledgement for a random amount of time, that random amount of time is called as backoff time. Backoff time. And that backoff time leads to transmitting the data again. If the stipulated time period, in that stipulated time period, if the acknowledgement is not received by the transmitting station, then it leads to transmitting the data again, retransmission of the data. So it keeps trying until the backoff limit is reached, after which it aborts the transmission. So here some of the formulas are used. What is this? Efficiency are also called as throughput. So the efficiency of pure Aloha is calculated by using the formula Z into e to the power of minus 2z. So this is the formula used for calculating the pure Aloha. Where Z, what is this? G means number of stations willing to transmit the data. So how many stations willing to transmit the data we will consider as Z value. So no, total number of stations. So how we will calculate the efficiency means efficiency or throughput. So the efficiency is calculated by using the formula G into e to the power of minus 2z. And we already told that the maximum throughput is occurred when the frames are transmitted. So how we will get the maximum throughput mean? By using the formula S is equal to S max. This is called as maximum throughput by using the formula of 1 by 2 E. So directly given the value as the maximum throughput of pure Aloha is 0.184. For G is equal to 0.5. So G value is considered as 0. We half of the frame, half of the means once the station is started, is ready to transmit the data. So we will consider the maximum efficiency of pure Aloha is 18.4 percentage. So why this is very less? Why this is very less means due to the collisions, the maximum efficiency of pure Aloha is 18.4 percentage. And here is one flow chart for the working principle of pure Aloha. So what is the working principle of pure Aloha means? First, um, it will start transmitting the data, and next it will set the backoff to 0. Backoff means the random amount time is set to 0. Next it starts sending the data packet, and after sending the data packet, the transmission station is in waiting state until the acknowledgement is received. So if the transmission station receives the acknowledgement, if it is yes, then successfully the data is transmitted to the receiver. If the acknowledgement is not received, so the condition is no, then increment the backoff, means increment the backoff value. Initially the backoff value is 0, now it is incremented to 1. Next, so we will increment the backoff limit, and we will check the condition that is reached the limit. So what is the limit here? We will set the timer. So if the timer is times out, then it will abort the case, means again retransmitted the data, or we will wait the backoff time. So it will check the backoff time whether the timer is timeout or not. If the timer times out, simply we abort the situation and again retransmitting the data. Otherwise, go back to the backoff time. So again same process is continued. So this is the working principle of pure Aloha. Clear? I think you people will understand what is the concept of pure Aloha.